Welcome, Math 13 students. I'm giving us our lecture on section 9.3, two dependent samples or matched pairs, as we like to refer to them. Here we're going to use the difference in matched pair values that we gather from samples. Common uses include before and after, husband versus wife, father versus son, mother versus daughter. You've seen a couple of examples already. You'll see one or two more as I go through my discussion. Let me start with some notation. Because we focus on the difference between sample values, little d is going to stand for our individual differences that we see between pairs in our samples. Mu sub d is going to be the population of all such differences. That's really the target population we are interested in. We have d bar will be the sample mean of the differences between the sample pairs, emphasis on pairs. S with the little d, that's my standard deviation for those pairs. And n is the total number of pairs that we work with. We're going to do a couple of things here in section 9.3. We're going to conduct a test of hypothesis, and we're going to build a confidence interval, very similar to what we did in section 9.2. We're going to be using the t-distribution, and because of that, we have the common set of requirements whenever we use our t-distribution. We want a simple random sample, and we need either or a sample size greater than 30 or a normally distributed population. We also need our data to come to us as matched pairs. Hey, if it's not matched pairs, it's a different set of data and a different tool perhaps that's required. So those are the requirements. And as I say, we're going to use a t-test to conduct our hypothesis test, and we'll use the t-interval tool when we construct our confidence interval. These are both in the test section of your stat menu on your TI-84. The biggest change is that we use sample data. And that means that we will actually need to carry out our work. We will need a total of 3 distinct lists. Perhaps list 1, list 2, and list 3. As you'll see, we really work with raw data a lot when we deal with the topic of matched pairs. So, let me give you a couple of examples here. Let me just start with a general example I think we can all understand. I want to consider a before and after situation where we are wondering if tutoring raises exam scores. We surely like to hope that tutoring helps exam scores, but how would we go about doing that? Well, we gather up a sample of students and we would measure them before. We would provide some sort of tutoring process, a treatment, if you will, and then we would measure them afterwards. Again, the same people, the before and the after. So you can see why we like this notion of dependent samples. If a person is in the first sample, they're going to be in the second sample, and we're going to compare them person by person. Not in any sort of random fashion between the before and the after. We want to know how you did before and how you did after. So we like our before and after data that way. So let me take a look at some made up numbers. Perhaps we went ahead and we tested some students before. We had a total of, let's see, we had a total of 1, 2, 3, 4, 5 observations altogether. And we tested students before, and we tested students after. They had some tutoring in the middle. We gave them a fairly standardized test. And what we really want to know if there is a difference in the before and the after. Now, typically we do before minus after. So there's a big subtraction in here. So it's 71 minus 76. 71 minus 76, you'll notice, ends up being a negative number. That's because the exam score went up. So in this particular case, if the difference is negative, here's another one. When we do the subtraction, we got a negative value. This one, however, when we did the subtraction, we ended up with a positive value. Their score actually went down. This particular individual here had no change at all, and this individual here improved also. So one of the things I'll talk about is the direction of what improvement might mean. You'll notice here that the actual data we are interested in isn't the before data, isn't the after data. The actual sample data we are interested in is right here. It's the difference data. And we're really studying the population of all before tests and all after test differences. That's the real population. It's the difference, neither the before nor the after. So there's a simple example of how this is going to play out. So let's talk a little bit about the test itself, and then I'll run through an example. So when we conduct a test of hypothesis, we're going to test claims about the mean population difference. We're going to use a p-value approach with raw data in list 3. And I'll show you how we develop that data. I'll have given data in list 1 and given data in list 2, and I'll want to do a little bit of subtraction pairwise to find the data in list 3. Now my calculator will make that very helpful. The hypotheses, well, the null hypothesis, as always, contains equality. That's going to be the hypothesis there is no difference or effect between the before and the after, and the treatment really has done nothing to change things. The hypothesis, alternative hypothesis, can be the usual left tail, right tail, or two-tail test. And I'll have something to say about each of those as we go along. So let me get to my example. That's really probably the best way to get into the topic. I'm going to show you some data in just a moment, and we're going to ask the question, does hypnotism help reduce chronic pain? Pain can be measured on a scale. I won't go into the details. And patients can be measured on that pain scale both before and after hypnotism treatment. Now, I've got my first couple of data points up there because I want to talk a little bit about what we can expect here. My first person here, their pain threshold actually went up, or I should say their pain level went up from a 6.6 to a 6.8. And I will notice that when I did my before minus my after, I ended up with a negative 0.2. That's a negative value. Now, in the grand scheme of things, this is not like an exam. This is pain. We want scores to go down in the afterlife. That didn't sound right. In the after world. So, pain there went up. That's not what we want to see. However, here's the second person in my hypnotism treatment group. They measured 6.5 units of pain prior to treatment. After treatment, that pain level had dropped to 2.4. So here, my before minus my after results in a positive value. Now, this is what we would like to see if we are going to go ahead and reduce chronic pain. So this is how we lay our hands on the actual claim. The actual claim to reduce pain means we want my mu sub d to be greater than 0, i.e. a positive number. That's what we're looking for. So here's my data set. I showed you the first two values. Let me show you the second two values. So there's my before pain levels. There was a hypnotism treatment somewhere in the middle here. Then the pain levels were measured again. You can see some went up, but a lot of them also went down. So what we need to do is we need to figure out the table of differences here. And this is actually our sample that we are interested in. I'm not going to go ahead and put that in there. I'm going to let my calculator work on that, but we are going to test the claim hypnotism reduces pain. And we're going to use an alpha equals 5% level of significance. Now, as I've already pointed out, this is the initial claim. The populations of differences is greater than 0. So let me go ahead and get my test started. There, mu sub d equals 0. Mu sub d is greater than 0. And again, I will note that I've got my initial claim. That's the claim of effective treatment right there. So let me jump over to my calculator and we'll show you how to deal with this type of data. There's my calculator. So I've already gone ahead and placed that data into list 1 and list 2. Now, I want to go through this list pair by pair and figure out the differences, but I'm not going to do that longhand. My calculator is quite capable of doing that in some sort of batch fashion. I highlight the name of the list. It's very important to highlight the name of the list, otherwise all you get is error messages. Down here in the little window, I see L3. Now what I want to do is I want to take the value in list 1 and subtract from that the value in list 2. And it's going to go through that list and do all of the subtraction for me. It's very important that I have the same number of numbers in each list. If the lists are different, have different values of numbers, then this won't work. So I'll go ahead and hit enter, and there we go. Those are my differences. You'll notice in the first case, we've got a negative difference. That was the one we looked at. There's the second case, 4.1, pain was reduced. In fact, in every case other than this first case, pain has been reduced. So there is the data set that I am interested in. Now I can go ahead and conduct my test of hypothesis. I'll pick up t-test, and chances are it's probably in stat mode. I'll need to point it at the data mode. There's my null hypothesis of a difference of 0. I've pointed it at list 3, and I've selected the right tail test because that's what we want, a positive difference. And now I can hit calculate, and I've got a p-value of 0.009477, so 0.00948. So let me go ahead stop my sharing. There's my p-value. I'll compare it to my alpha, very much less than. That means we reject the null hypothesis. So at alpha equals 5%, excuse me, I'm spacing out. Data support, u sub d is greater than 0. So hypnotism seems to work when it comes to reducing chronic pain. At least for most of the people in that test. It certainly didn't work for the first person. So remember, these are statements that apply to broad populations. As the commercials like to say, your experience may vary. Now, let me go ahead and construct the 95% confidence interval for the same measure. So confidence interval for pain reduction. So let me come back and share. I don't need to enter in data again. I can run straight to my calculator and pick up the t interval. I've got data in list 3, and we're calculating the 95%, confidence interval. There's my point estimate, by the way, 3.125, and my confidence interval going from 0.69 to 5.5 and change. So 0.7 less than mu sub d, less than 5.6. And I will note that d bar, the mean of those differences, was 3.125. All right, so let me go ahead and stop my sharing and just talk about this confidence interval for a moment. What this confidence interval means is that if you have chronic pain and you're normal, if you will, or average, if you will, then if you do this sort of hypnotism, you can expect a reduction in your pain level of between 0.7 and 5.6, whatever those units of pain might be. Average pain reduction, 3.125 units if you've done the hypnotism. You'll notice these values are positive. That's because we went from a high value to a low value when this treatment was effective. In fact, let me close with that notion. The match pairs challenge. The direction of effective treatment is important. For example, the last problem we looked at, the claim of reduced pain. We saw for that person, the first person who actually had a reduction of pain, we saw that the difference was a positive value. Therefore, the mean difference for the mean of the differences should be greater than 0. On the other hand, that earlier example we looked at, improving test scores, this one also was a good outcome, and we ended up with a negative difference. That's because when exam scores go up, the small minus the large gives you a negative number. So sometimes we have big minus small, which means we end up with a positive difference. Sometimes we have small minus big, and we end up with a negative difference. So figuring out which of these two cases is the case for your particular problem is the match pairs challenge. So take a look at that. There's more videos in the Canvas course shell. And reach out with questions and shoot me any email when you get stuck. And we'll take it from there. So thank you for listening. I'm going to go ahead and stop my recording and we'll be done.